Hi guys, today our notes are going to be graphing logarithms. So we're going to be on slide 12 through 14 today for our notes. At the top of your paper you can go ahead and put notes logarithm graphs, and then we'll start with graphs of logarithms. So what you need to remember about inverses is that the inverse of a log is exponential. The inverse of an exponential is log. So if you remember when you graphed exponential curves back in Integrated Math 1, hopefully you remember that, they looked like curves, and then the inverse, the log graph, is just going to be a reflection of that across the line y equals x. So the graph of a log is the reflection across the line y equals x of an exponential curve. So if you remember, like I said from Integrated Math 1, an exponential growth curve has a horizontal asymptote, so it's really, really flat, and then it just starts kind of going up. So if you imagine we reflected it across the line y equals x, wasn't great, but here's the line y equals x. This is an exponential growth curve. So if you imagine reflecting it across that axis, instead of having a horizontal asymptote, it's going to have a vertical asymptote. So it's going to go kind of straight up, and then it'll curve. This is a log graph. So the general form of a log graph looks like this. F of x equals a times log base b of x minus h plus k. So you can go ahead and write that down, and we'll talk about what each of those little pieces does to the log graph. So the a, this little piece in the front, what that will do to your graph is a vertical stretch. If it is negative, that means it's going to reflect it across the x-axis. The next piece is your, we're going to talk about if there is a h value. The h value is a really important one. This is your horizontal shift. So this moves it left and right. It's also the asymptote for your graph. The asymptote's a vertical asymptote, so it's going to be the line x equals h. What you need to remember about h is that you have to change the sign. It's opposite of what's in the parentheses. K is your vertical shift. That one you get to keep the sign. It will move your graph up and down. The only one other thing I wanted to note is if your x is negative, it reflects across the y-axis. So we're going to talk about kind of some steps for graphing, what the graphs will look like, and then we will do some examples. All right, so the first thing that you want to do, your first step for graphing, is you're going to look for your asymptote. So your asymptote is in the parentheses for h. You change the sign. So you just draw your vertical asymptote. At x equals h. Step 2, you're going to make a t-chart with 3 points. And then you're going to go ahead and connect with a smooth curve. So when we talk about the vertical asymptote, when I draw my little graph, Your asymptote, I just draw like a little dashed line at x equals h. That's the line. An asymptote is a line that your graph's going to get really, really close to but never actually touch. Then when you make your t-chart, I said to make pick 3 points. You just pick 3 numbers on the right side of your asymptote. Unless your x was negative, then you would go on the left side. So a positive, it would be like this. But if you have a negative x, then it's going to be on this side. Then to get the y's, you just plug in those x values. A little note or something that you want to use when you're picking these values. You want to pick things that you can evaluate using like the loop trick, like mental math. You want to use like log base b of b equals 1 and log base b of 1 equals 0, that kind of thing. The last thing I want to mention is our domain and range, and then we'll go do some examples. So the domain is your x values. It's usually just from h to positive infinity. Remember, the parentheses means like a close or an open circle. You can't actually get to h. That's because h is an asymptote, so you can't actually get to h, and then infinity, you can't actually get to infinity either. Unless your x was negative, then it's the other way. Then you would use from negative infinity up until h to be on the left side of the graph. And then your range is your y values, and your range is just always from negative infinity to positive infinity. Okay. All right, so let's go do some examples. So this is going to go in our notes. I think it's slide 12, so I'll take a picture of this. But now we're going to go ahead and go do some examples. This is in your workbook, Unit 4A. And I hope if I knew the page. This is page 59. So this is on page 59 of your workbook. We're not really going to do any of these steps that they have. We're going to go ahead and just graph our own or do our own graphs. We are going to graph them on the same page. So the two equations that we're going to graph, so sketch the graphs 2 times log base 2 of x and g of x equals 2 minus log base 2 of x on the coordinate plane. Describe the end behavior. We're just not going to go ahead and do that part. Okay, so I'm going to try to do 2 different colors, graph them on the same graph. So here's our first one. So the first thing that you want to do is go ahead and identify your asymptote. So your asymptote is the number that's inside the parentheses. Notice we don't have any parentheses. That just means that our asymptote is going to go ahead and be at x equals 0. So x equals 0, that's going to be a vertical line just on the y-axis. That's the line that our graph's going to get really, really close to but never actually touch. Okay. Then we make a t-chart. We want to pick 3 numbers on the right-hand side of this graph. Okay, so we're going to pick positive numbers on the right-hand side. So I'm just going to pick like 1, 2, and there's a log base 2 right here, and 8. And I'll show you why I picked those numbers. Okay, so when I go to plug them in, I have 2 times log base 2 of, and then I'm plugging in where the x is, I'm plugging in the number 1. Well, the reason why I would want to pick 1 is because we know this question you ask yourself is 2 to what power is 1? Well, that answer is just 0. So 2 times 0 is 0. Then I'm going to plug in 2 times log base 2 of 2. And then remember the question you ask yourself here is 2 to what power is 2? And that answer is just 1. So 2 times 1 is 2. I could have picked any numbers. I could have picked 3, 4, 5, 6, 7, 8, any of those numbers. But I picked 8. The reason why is I wanted something a little bit further out. And then I picked something that was the base 2. I picked 2 cubed because if you plug in an 8 here for the x, 2 to what power is 8? That answer is 3. So 2 times 3 is 6. So I'm just going to plot those points. So I have 1, 0. That means you go right 1, but not up or down at all. 2, 2 means right 2, up 2. 8, 6 means I go right 8, up 6. And those are my 3 points. So when I connect them with a smooth curve, I start at the bottom at my asymptote, and I just draw like a straight line next to your asymptote. And then once I get to my points, I just make a smooth curve and connect them. So this was f of x. I'm going to do g of x. It's going to be on the same graph. I'm just going to use a different color. Okay, so g of x is 2 minus log base 2 of x. So again, the first thing I'm going to do is identify my asymptote. So there's no parentheses. That means my asymptote is just at 0 again. So it's on the same little axis, y-axis. Then I'm going to make my little t-chart. Since this one is also a log base 2, I'm going to use the same numbers, 1, 2, and 8. You can use any numbers that you want to the right, but the reason why I would choose those is because you want this number right here to match this base, be like that number 2 squared, 2 cubed, 2 to the power of 0, those things. All right, so this time I'm plugging it in. 2 minus log base 2 of 1. Well, remember the question you ask yourself is 2 to what power is 1? That answer is 0. 2 minus 0 is 2. Then I plug in 2. 2 minus log base 2 of 2. 2 squared, or no, 2 to what power is 2? That's power of 1. 2 minus 1 is 1. And then lastly, 2 minus log base 2 of 8. 2 to what power is 8? That answer is 3. 2 minus 3 is negative 1. Hypothetically speaking, let's say you chose like a 5 here. You would have 2 minus log base 2 of 5. That's okay. You would just have to use your calculator for this, and you would have some sort of decimal. Okay, so you could do it. You would just have some sort of decimal, and you can use your calculator if you need to. All right, now I'm going to plot those points. So 1, 2 means right 1, up 2. 2, 1 means right 2, up 1. And then 8, negative 1 means right 8, down 1. So if you notice how this one right here, this value is your A. Your A is negative here. This is technically your K. Normally it's written at the end. But here your A is negative. That means that my graph is a reflection across the x-axis, which means instead of starting at the bottom, you actually start at the top. Work your way down next to your asymptote, and then once you hit your points, you just connect them with a smooth curve. That one's g of x. So since your A was negative here, that's what made it flip across the x-axis. Instead of going from the bottom up, it starts from the top down. All right, let's flip this one over to page 60, and I'm going to change these instructions for this one as well. It says sketch the graphs of, and then it has a couple of equations. We're just going to cross that off. I'm not going to describe the end behavior. We're not going to use a graphing calculator or anything. We're just going to do f of x equals, and then I'm just going to do log base 3 of negative x. We'll do plus 1 in parentheses. There we go. All right, so I changed my problem a little bit. So the first thing you want to do is identify your asymptote. So your asymptote, you look in your parentheses, and it's the opposite of what it says. So your asymptote is going to be at negative 1. So I have my asymptote over here at negative 1. Then you go ahead and plot your points. So notice how this time my x is negative. What that means is instead of picking numbers to the right of my graph, if your x is negative, I'm actually going to pick numbers on the left-hand side of the graph. So I'm going to pick negative 2. I'm going to pick, let's see, negative 2. Negative 8. Trying to think of numbers that are going to work for me. Oh, you know what? I think I made a mistake on my asymptote. Okay. Since my x was negative, my asymptote is actually at +1 because you're basically deciding what would make 0 here. So if x was a +1, -1 and +1 would cancel each other out. So since x is negative, my asymptote is actually at this positive number. So if your x is negative, then you actually get to keep the sign of this one. So the numbers I'm actually going to choose are 0, -2, and then -8. So I'm still picking numbers that are on the left. I'm trying to pick numbers that are good ones. You can pick any numbers that you want. You just might have to use your calculator if you don't pick ones that are like perfect numbers with the base 3. All right, so I have log base 3 of plugging in 0 plus 1. So remember, 3 to what power is 1? Well, that's just 0. Anything to the power of 0, or yeah, is 1. And then I'm going to plug in -2. So I have log base 3 of -2 plus 1. Well, -2 plus 1. I'm plugging in -2 to my -x. So that turns into a +2. So that's a 3. 3 to what power is 3? Well, that answer is 1. Then I'm plugging in 8, -8, log base 3, -8 plus 1. So 8 plus 1 is 9. 3 to what power is 9? 2. So I plot my points at 0, 0, -2, 1, and -8, 2. All right, so notice how these points are on the left-hand side. So it starts at your asymptote, it's going to go up, and then this time it's curving to the left. So that's what happens when your x is negative. When your x is negative, you actually get to keep the sign for your asymptote. And then when x is negative, it actually goes on the left-hand side of the graph. All right, one last example, and it says use the graph of the function f of x to write the algebraic form f of x. Assume that f of x is in the form of a times log base 4 x plus b and includes the point 15, 4. Then describe how to find the common solution for f of x and g of x, which is 3 times log base 4 of x. This common solution, so see there's the two graphs. The common solution is just where they intersect. Okay, so now let's go write the equation. So on your quizzes, it's going to give you a graph and then you have to match the equation to it. So here's how you want to go about that. So here's f of x. The first thing you want to look at is the asymptote. So here's f of x. My asymptote, if you guys notice, is this vertical line, and it happens to be at -1. That means when you plug it in your parentheses, it's going to be at +1 because it's the opposite sign. So a times log base 4 of x plus 1. So that's the first thing you can identify when you're trying to match an equation to a graph, is you first want to just identify where the asymptote is, and then the opposite number will go in the parentheses. So my asymptote was at -1. So in my parentheses is going to be a +1. The next thing that we need to find, the only other thing that we need to find here is a. So in order to find that, because they already told us it was a log base 4, in order to find a, we're going to take this point. We have an x and a y. So y is your f of x, that's 4. A is what we're trying to find, times log base 4. X is 15, so that's 15 plus 1. Well, 15 plus 1 is 16, so you ask yourself the question, 4 to what power is 16? That's 2. So we get 4 equals a times 2. Divide both sides by 2, and we get a equals 2. So the equation of our graph, f of x, our a is 2 times log base 4 of x plus 1. So how you can write the equation of the graph is you first identify your asymptote. Okay, so you first identify your asymptote. Use that -1, so you put +1 in your parentheses. And then in order to find your a piece, we just picked a point. Okay, we had the point 15, 4, and we plugged in the y is 4, the x is 15, and then we just solved for our a of 2, and then we have our equation. All right, so this is going to go in on slide 12 for the notes. Example 1 goes on slide 13. Example 2 and 3 goes on slide 14. And the homework is on quizzes.